Hi folks, Transit Diaries here, hope all is well. This video was originally intended to be a lot longer than this, but I'm having great technical issues because it's over an hour long basically, but so I've come across issues that I didn't have with my other videos, and maybe divine intervention has intervened. Anyway, but just a brief introduction. I'm doing a little project, and I've quite an extensive skill base, should I say, and I'm just, you're getting a fly on the wall view of the kind of projects that I'm at. I like building stuff and I like working with my hands, and I find it very therapeutic. I think most people do. But that's by the by. But so this is just like a little brief introduction of what this is about. So hope you enjoy. Now folks, sorry about the quite crude filming techniques used here, but I am a carpenter after all, so I get a free pass. Anyway, in this very rough diagram you get an idea of what I'm talking about. This is basically our fireplace. And as I said before, you know, quite a lot of heat can build up here. If there's a failure in the circulation pump, the system, electricity goes off, a variety of reasons. So we have to mitigate some way of releasing pressure. And I'll give you an idea. A drop of water expands 1400 times its own mass when it passes 100 degrees Celsius. So it gives you an idea of the kind of pressures we're talking about, and that will blow 8-inch steel apart if it has to. So we've got a way to release. We have to have a way to release that pressure in case that happens. All boiler engines, steam engines, have safety valves, for example, and this is our version of a safety valve. This is effectively a steam engine without the engine. That's effectively what this is. So this is what we call a flow in European money and a return. But the concept, I'm sure, is the same the world over. I believe physics applies the world over. I don't know of any nation where a head of water is different from one nation to another. So I'm going to assume it's the same the world over. So the property in question is 2-story, so that's my first floor. This is the ground first floor, and that's my attic. Now, flow return, and this is a vent pipe, as we call it. Now, traditionally there's a tank in underneath here, and this is called an expansion tank. But some people get quite cheeky, and this is a loop here, and they just put a pipe from here to here, and this tank doubles as an expansion tank and a flow, or sorry, a feed tank, whichever way you like to look at that. Now, I'm going to revise this slightly. The systems, the patent systems I've been looking at, there's a variety of heat plate exchangers. They're called safety release valves, and so on and whatnot. So there's a rake of extra piping, and not only that, but all this equipment has to be serviced regularly to make sure that it'll work in case there is a failure in the system somewhere. So my system compromises of everything of the above here, as you see it. And what I'm going to do is I'm going to have another tank up here. So this is going to, instead of having one, which is traditionally the way people go with this, I'm going to have 2. So this is going to be effectively what I would call, let's rename it, an overflow tank, this here. And this is going to be a feed tank. So this pipe here is going to be 3/4 inch all the way up, and this is going to be 1/2 inch. The feed is going to be 1/2 inch. So I'm going to bring this pipe down here, and then I'm going to bung it into this side of the boiler. Now I haven't decided whether I was going to go for the top or the bottom, because obviously the water is hotter up here, than it is down there, and I may choose the top because that's what this system is trying to do. Cool the boiler down in case there is a malfunction somewhere in the system. That's the objective, should I say. So what I'm guessing is it's very important that the head of water in this tank has a direct relation to this loop here, this U here. And the reason for that is quite simple. I light my fire, water heats up. As it heats up, it expands. So obviously we have to allow for that. So water is going to make its way up this pipe. Now, it'll take a bit of tuning, but I have to get the water level here correct with this. So at 100 degrees, for example, the water is going to start boiling, and it's going to start forcing water up this pipe. And once it does, it's going to throw it over that U. It's like almost over the side of a waterfall. But it's very important that this pipe is here. And we're talking about maybe the guts of 2 meters of a fall here into this tank. And once the water starts falling into that, it's going to create a siphon effect. This is more or less how your toilet works when you flush it every time. It's going to create a siphon effect, so it creates a vacuum in this side of the pipe. So the water coming down here draws the water coming up there. So obviously that water has to be replaced by somewhere. And my theory is that it will be replaced by the cool water in this tank coming down this 1/2 inch line. So effectively what happens is you create a circuit where this water, the hot water, starts spewing into this overflow tank and starts draining away harmlessly. And it starts drawing cool water down into the boiler here, which is the objective. This is exactly what we're trying to achieve here. And so after there's about 5 gallons of water in this. So once it is flushed 5 gallons of water, obviously this water line is going to come down. And once it hits the level of this tank, the siphon effect will, well, basically the pressure in here and here will equalize. There'll be no longer a vacuum and it's going to stop. Then the water is going to build. This tank is going to start filling itself back up again, just like your toilet. And the level will reset itself again. And it's effectively, for the want of a better word, rearmed to repeat the cycle infinitely. This is the theory. Now, from the outset, I just have one issue with this, is that one place of concern for me is I may even go inch on this pipe. I've already allowed 3/4. I may go inch. That'd be 28 mil in European money. And the reason, and I may go 15 mil or 1/2 inch on this. Well, I'll definitely go 15 mil or 1/2 inch on that one. The reason for that is simple. When the pressure builds up, obviously water, like electricity, like most other things, looks for the path of least resistance. Just look at a river, for example. It doesn't flow uphill. When it meets an object, it tries to move around it. It doesn't try to force that object out of the way. And water, since this is a bigger pipe than that is, it's going to want to go up there and create the circuit. If I were to make these 2 pipes the same size, chances are this water would boil and it would force, maybe even force this tank to actually overflow. That would be a risk. Now, if that fails, what I can also do is I can put a non-return valve on this. So I'm going to try this first of all, see if it works. And if it doesn't, I'm going to put a non-return valve here. So it'll have no other choice but to create that circuit. So this is basically the theory behind this. And let's see whether it works in practice. So you get an idea of what I'm talking about anyway. So here's the fireplace in question that I'm going to fit basically that back boiler into here. Now I realise I have this little mic on here, and the reason for that is quite a lot of people pass comments that the audio is quite poor in my video, so I'm trying to improve it here. But as I say, this is all a big learning process for me. But anyway, I'm a carpenter, so anyway, so this back boiler is going in here. So if you try to visualize that sketch that I had just after showing you, basically she goes in there. So I'll have to drill a hole there for my flow, my return, and this will be for my feed. So 2 pipes are going to go up here, and they're obviously going to continue on up through the story above me, and 1 1/2-inch pipe is going to come down here into the side of this. As you can see, this isn't a solid chimney breast. I've done a few bits and pieces here, just like little trials, just to see how far I can get here. And maybe I should have showed that in the video, in other videos, but because it is all related ultimately. But anyway, the bottom line is I'm going to put that back boiler in there, which is going to power all the central heating effectively in this house. And a big concern when you're fitting a system like this is the position of the pump. And one crucial thing, but I will explain that in better detail in later videos, is the position of the pump relative to the vent pipe. That is crucial. Nearly always, but sometimes the design of a house doesn't permit this. Nearly always, it's optimal, should I say, that you fit the central heating pump on the flow after the vent pipe, because it has a nasty, if you put it before the vent pipe, has a nasty tendency, depending on how much resistance there is in the heating system, you might have to power up that pump, and when you do, it sometimes just pumps water directly into the expansion tank, rather than, like as I mentioned before, water takes the path of least resistance. So if there's less resistance with just pumping it up 2 meters into a tank than there is doing like a 60 or 70 foot circuit in a house, then it's obviously going to do that. So you just got to keep these things in mind, but that's for a later video. The main thing I'm trying to achieve here is fit this boiler, get my flow, my return in, get this feed tank, get the tank set up on the roof, and then I'm going to light me a fire and see if this system works. That's basically what the aim is for now. Afterwards, we'll go into greater detail of how I'm going to put the circulation pump in. So basically that's it. I don't think it needs any more intellectualizing than that. I will just I'll just take that camera off there a second, and you take a look at this. You can take a look at this boiler here. Now this is an old boiler basically that was thrown out, and the reason I'm using this boiler is well, I got it for free, for example, and around here they are the best back boilers. They are the best back boilers because they're very good at recuperating the heat. So you have your little fire in here. Now there are steel plates on this, but it'll all become clear in a moment. Basically the fire goes through here, has to go around there, up there, and back out to get out. So it's getting most efficiency out of the fire itself. Now I'm going to obviously modify this design a bit. What I'm going to do is I have my little hinges, steel hinges. I'm going to put 2 little doors on this and a damper plate down here. There's going to be another mechanism up here. It's like a sliding plate. So when the flue can either, when the plate is closed, pushed back and closed up here, the fire just wants to come out and just head up in front of this main boiler unit here. And that's good for pumping out some heat directly into the room that the fire is in. But if you want to generate hot water, then you pull a little damper, it shuts off this section and it opens it up there. So it creates a draft here, and obviously the heat, the gases and the flames have to follow that path to get out. So the fire goes in and up around the back. Sorry, you might be able to see that clearly, but you can do that. Are you with me? So you can see the concepts, and these are undoubtedly the most efficient back boilers that I know of anyway. They're still making them, exact copies of this one. This one is an 18 inch, you can get them in 16 also, but I think I'll know shortly, but I'm nearly sure I'll stick with the 18, the bigger the better. And I can get just an exact copy of this boiler again, brand new, for 400 quid. So I can literally use this as like a dummy boiler. And basically I plumb it up and it's acting like a template, so I can design the whole system around this boiler. And then I want to prove my the theory correct, and if it is correct, well then obviously I'll go and purchase a brand new one of these. I wouldn't advise people to fit second-hand back boilers. It's not a good policy, and here's why. Usually when something is thrown to one side or thrown out, there's a reason for that. And shock horror, I found the reason that this one was thrown out to one side. And as you can see here, I'll just move in a bit closer. You can see that there is a little bit of weld, a little bit of spot weld that I had to put on this. So what I done was I bought these two brass fittings that you need. I bought them two. I blanked that, stuck a 1/2 inch pipe, stuck a hose on it, and I put the fitting on this so I can get the water in here, and I blanked that, and then I let the pressure in here, and obviously I used the blanking plate up here as almost a bleeding valve, just to let the air out, because it's important that all the air comes out, and as soon as you see water then spitting out there, you tighten that up. And then I pressured the whole thing up to 3 bar to see whether there was any leaks in it, and lo and behold, it started spewing water right out there. So I drained all the water out, put that spot weld on it, and pressured it up again, and it's as tight as a duck's arse, as we say in the construction industry at the moment. So it's well in good enough order for me to carry out this experiment, at least with it. So that's my plan. In with that boiler, which literally goes in here. So it literally goes in here, so I have to drill holes here, here and there for... I definitely think I'm going to pick the top for my feed. That's my flow, and that's my return. So the next mission here is to... Now it is about 100 mil or 4 inches of concrete here, so I have core drills, but it's quite a job. You have to do one about there and one about here, 3 in all, and it's quite a job, so that's going to take me a while to get through them. I'll see if my core drills work. If they don't, I'll just use a Kango on it. But So, and I have to go ripping out some more plaster work here. I have to butcher out some of this plaster work just to get the fittings in, and obviously the pipes just head up onto the next, and I have to find a way of feeding them through. But I'll be showing all that anyway in the next couple of videos, but you get the idea of what I'm looking at. Just by the way, as I said, this boiler is 400 yo-yos was the last price I got in a brand new one of these boilers. Now I have the fittings already, I can take all these off, and this is one thing to remember when you are plumbing. You wouldn't believe how many of these kind of fittings you need, and elbows, and it adds up, believe me, it does. So you obviously try to design a system as cleanly as possible that you don't end up buying all these fittings. But anyway, but that boiler, 400 yo-yos. If I were to buy a boiler for an open fireplace like so from a reputable manufacturer, the price I got was 1,700 euros. Are you with me? So all I'm going to do is put 2 plates on the front of this, and I'm going to save myself, what's that, 1,300 euro. Are you with me? So there's a little builder's trick for you. First off, the reason I'm going with this system, you see, is I like open fires. The yoke, it's the ones, they have a big glass door here, and you can't leave the door open effectively. They're not designed to do that. So they're like effectively an inset stove rather than an open fire. Whereas this one, I can make it into a stove because I'm going to put the doors and the damper here, or you can have it as an open fire. So it gives you both options, and it does both options quite well. But I like open fires. I just like the naked flame of a fire in a room. There's something tremendously primal about it. And actually, it's known facts. If you look back at human history, you know, you look back at prehistoric man, at night time, that's what they would do. They would congregate around the fire. So the fire really, of recent times, has been replaced by, well, there used to be a television there. I don't have one anymore, thankfully. But the television replaced the fire set as the central social area around the house. And now I'm stealing back the fireplace as the central place by which all things are done around the house. And I honestly can say that sometimes when I feel a little blue down, a little overrun by my life or whatever else, I gotta say, sometimes you light a nice fire, get a cup of tea, and just stare into the flames for a while, and you begin to feel better. And so there's about 250,000 years of evolution supporting that claim. So I would tend to think it's true. So I aim to save 1,300 yo-yos by buying one of these. I remember all the plumbing I would have to do for either system anyway, so I'm afraid there's no way I can save on that. If I were to use some of the sophisticated systems, painting systems I was telling you earlier on, there's a heat play, double the pipe work, more inlets, outlets, blah, blah, blah. You have to add on more for pipe work, fittings, labour. And then the system itself, the last quote I got was 700 yo-yos. So the system I'm installing here, I aim to save £2,000 straight away by installing this system. So if you just take a look at what the next couple of videos, you might be able to do the same thing. It's not rocket science, but just remember, there are a couple of basic rules that you have to pay strict attention to. Because we are dealing with steam here, so
So it's important, let me put it that way, but not impossible. So anyway, that's gives you the heads up on what I'm trying to achieve here, and talk to you later. Good luck.